Hello everyone, Mr. Kaczynski here, working out of Section T, Linear Inequalities in IXL's Algebra 1 skills. This skill, SGH, is solve systems of linear inequalities by graphing. Really the best way to show solutions to systems of linear inequalities is by graphing them. Alright, so 5 examples for you, progressively getting more difficult. Okay. This one confuses some people right off the bat because some people get confused about how to even graph x equals 1, let alone x is less than 1. X equals 1 would just be a vertical line at 1. Since this is x is less than 1, it's an inequality. So the line itself would be a dotted line, vertical line at 1. And since it's less than 1, we would shade everything to the left of it to show it. However, we're doing a system, so we're going to wait on the shading till the end. X greater than or equal to -3. That would be a vertical line at -3. And again, it's dotted because it's greater than as opposed to greater than or equal to. If it was the or equal to, we would have solid lines here. All right, and then lastly, we need to determine our shading. So I'll get some colored markers out here. X is a less than 1. That would be these values going this way. X is greater than -3. That would be these values going this way. So the shading that we're going to include is everything in the middle of this. So that purple area right there are all the points that solve both of these inequalities. All right, let's move it on. Now we have y is less than or equal to 7, okay? So that is going to be a horizontal line at 7 as opposed to a vertical, which would be x equals 7. So it's going to be a horizontal line at 7. All right, it's solid because it's or equal to. So these points that are on that line actually do solve that inequality. Next up, y is greater than or equal to -3x plus 7. So 7 is our y-intercept, and then from there we'll go down 3 and right 1 to show our slope. So 7, down 3, right 1. There's our slope. Now as far as shading goes, I'll grab my colored pencil here. Y is less than 7. That would be all of these values right here. And then with this one, okay, that's a little bit tougher. How about we just, check this point 0, 0. Is 0 greater than or equal to -3 times 0 plus 7? Or is 0 greater than or equal to 7? It's not. So since that point doesn't work, we would be talking about shading this side. So what do we got here? We don't need to worry about that anymore. We're just talking about this section over here where their shading would overlap. And that's the solution set. All these points in this section would solve both of these inequalities. All right, a couple things here. Number one, I've got a greater than sign and I've got a greater than or equal to sign. That means I'm going to have a dotted line and I'm going to have a dashed line. Here we go. So this purple line here is going to be have a y-intercept of 4 and a slope of -2. That looks like this. Y-intercept of 4, slope is down 2, right 1. Dotted line because it's or equal to, because it's not or equal to. It's just greater than. So the points on that line are not solutions to that linear inequality. Next, the orange one there. Y-intercept of -9, slope of 2. Y-intercept of -9, slope of 2. It's a solid line because the points on this line do solve that inequality because it's or equal to. Now as far as our shading goes, and this is where we got to do a little bit of work here. If I plug 0, 0 into this point, let's see if it works. If it works, we'll shade that side. If it doesn't work, we'll shade the other side. Is 0 greater than -2 times 0 plus 4? Some of this is, work that you can do in your head too, because -2 times anything will be, or times anything times 0 will be 0. So is 0 greater than 4? It's not. That's not a true statement. So we wouldn't shade that side. So as of right now, we're shading that side. All right. What about the other one here? 0. Let's check the point 0, 0. 2 times 0 minus 9. Is 0 greater than or equal to -9? Now that is a true statement. So we would be shading this side, the side that does include the point 0, 0. So then I grab my eraser and I think, okay, this is the section I want. So I'm not going to worry about that. I'm not going to worry about that. That's the section that includes all the points that are solutions to this system of linear inequalities. Okay, so this one's getting a little bit tougher here. I'm going to grab my orange pen here. And number one, I need to solve this for y so I can put it into slope-intercept form. So I'm going to subtract y from both sides. That's going to give me 5y equals -x plus 35. And then I'm going to divide both sides by 5. That's going to give me -1/5 x plus 7. -1 divided by 5 is -1/5. 35 divided by 5 is 7. So when I graph this, it's going to have a y-intercept of 7 and a slope of -1/5, meaning down 1, right 5. Notice it is a dashed line because it's just less than, it's not less than or equal to. The second one, thankfully, makes our work a lot easier, is in slope-intercept form. It's going to have a y-intercept of -9 and a slope of 3. Y-intercept of -9, slope up 3, right 1, solid line, because all the points on that line are solutions to the inequality. The or equal to tells you that. Shading, okay. For the orange one, it's kind of, just think about it. If you plug 0 plus 5 times 0, if you plug the point 0, 0 into this equation, 0 plus 5 times 0 is 0. So is 0 less than or equal to 35? Yes, it is. That's just easy mental math. Okay, we'll try the same thing here with the green too, even though it's in intercept form. 3 times 0 is 0, so it's just going to leave you with this -9. Is 0 less than or equal to -9? 0 is not less than or equal to -9, so we wouldn't shade the side that includes 0, 0. So where's our overlap? It's over here on the right side, so I'm going to erase these arrows, and that's going to be my solution set. Over here. All these points over here are the points that solve this system of linear inequalities. One more. I think I can fit this in and get a good explanation and maybe be under 10 minutes, maybe not, because look at this guy. It's a tough one here. So grab my purple here, and what I'm going to do is I'm going to take this equation and I'm going to solve it for y. So I'm going to add 2x or 5x to both sides. 2y is greater than or equal to 5x minus 6. Then I'm going to divide both sides by 2. Y is greater than or equal to 5/2 x minus 3. 5/2, -6 divided by 2 is -3. All right, so when we graph this, it's going to have a y-intercept of -3 and a slope of 5/2, up 5, right 2 from there. It is a solid line. There's so many things places where we can make mistakes. Y-intercept, slope, dotted line or solid line, side of shading. You really got to take your time on this, okay? We'll wait on the shading here for a little bit. All right, let's go to this. I'm going to call it orange. Okay, and we're going to do the same idea, but this one we can do in just one step. We just have to divide both sides by -100. Technically, when you divide both sides by a negative, you're supposed to flip the inequality. Don't forget about that. -500 divided by -100 is 5. And 90 divided by -100, it's a positive divided by a negative, which is a negative. 90 over 100 is 9 over 10. Fractions are going to be your friend here, okay? So when I graph this one, it's going to have a y-intercept of 5, and then from there I'll go down 9, right 10. So y-intercept of 5, down 9, right 10. Notice it's a dashed line because it's just less than or it's just greater than. It's not less than or equal to. Shading. All right. We want to think about this, okay? If we do 0 in for x and y, we're just going to have 0 on this left side. Is 0 greater than or equal to -6? Yes, it is. So this is the side we would want to shade for that one. Oops, actually I want to look at the purple one. Don't want to mess that up now. So 0, 0 on the purple one is what we would want. Yeah, so that would be this side right here. Okay, as far as the orange one goes, if you plug 0 in there, you'll get 0. If you plug 0 in on the right, you'll get -500. Is 0 greater than -500? It actually is. So that would be this side. So the part where they overlap, where these both arrows are pointing at, that's going to be our solution set right there. This portion over here shows all the solutions to this linear inequality, system of linear inequalities. A lot going on there. Like I said, you got to take your time. You're going to make mistakes. You're going to be frustrated. Definitely get a piece of paper out when you're doing solving linear systems of linear inequalities by graphing. Okay, so you can put these into intercept form. You can check whether 0, 0 works in the inequality or not. Best of luck to you. Have a good one.